second problem. So look at this is again another interesting problem where I am going to look at motion of more particles. So for that I am going to describe you the system of connected bodies. System of connected bodies. Look at this system has got a pulley E, and there is a cable wound around the pulley. So that goes like this. And on the cable you have a block here. Say that block is C, block C. Other end of the cable has got another pulley. So in this pulley again you see there is a string going around, and you have two blocks at the two ends of this cable. So look at this is A, this is B. This is the kind of arrangement. So this pulley is pulley D, which is the moving pulley. This pulley can move, moving pulley, whereas this is the fixed pulley now. And this arrangement has got two strings. One is string DC, this is string 1, and there is string 2. There are two strings, and there are three blocks A, B, C. Blocks A, B, and C. So you are given the masses of these blocks. So what is mass of block A is 2 kg. Mass of block B is 4 kg. Mass of block C is 6 kgs. So heavier masses this block. So if you assume that this block comes down, this pulley, moving pulley goes up, and these two moves up. But if you look at B is heavier than this, so this block comes down, this A, so the motion becomes complex. The absolute motion of them is really complex. So you have to predict this absolute motion. That's the question. So determine acceleration of these blocks. So what is the question is determine the accelerations of these blocks. That's the question. Right? Any doubt? So how do you solve this problem is what is coming under the category of dependent motion. Dependent motion. So motion of C depends upon motion of D, motion of B depends on motion of A, and so on. So in this again you see this pulley D and E masses are not given. That means you can neglect those masses. Those are guide pulleys. The mass of the block and this pulley masses will be negligible. Maybe they are in some few grams. So you neglect that in the analysis. So mass of D and mass of E are neglected. So that's what you have to consider. So now can you just solve this problem? So how do you go about solving this problem is there's something called the consistency of string law. That's very important. So whenever you have this type of connected block pulley system and they are connected by the cables called an inextensible cable, the length of the cable will not change. These cables in an industry, if you look at in a cranes to lift this kind of loads, they are steel wires. So the deformation will not be appreciated. That is not much. It is inextensible cable. So the length of this cables remains same. So the length of cable 1 and length of cable 2 remains same. So that helps us to have some additional equation. And those equations are obtained through the law called the consistency of string law, where the length of the cable under motion remains constant. So how do I represent that motion is what we are going to look at it. So using this, I'm going to generate some equation. addition to getting the equations of these three blocks applying Newton's law in order to find my acceleration. So acceleration of the blocks means it's absolute acceleration of the block is asked. What is AA, AB and AC? So this all I should find out. So for that I should have a reference in my system. I should have a reference point in the system. Whenever I have like this dependent motion problem, I should represent a reference which is the fixed point. So in this case, the fixed point will be point E. So let's look at this point as my reference. So the motion of the block of going down is referred by positive sign. If it goes up, it is negative sign. Like that, let me take. So initially, see, I know this heavier C comes down, D goes up. But what is happening with the B and C? So that's the confusion. So whenever I go with this kind of convention representation, I'll consider by default all the blocks are moving down, assuming they are positive displacement. Though it is not so, I'll assume and solve. Then I get a negative sign accordingly. That will be adjusted. So that's the procedure. So let us assume all block and the moving pulley moves downward direction. So all goes downward direction. If you assume like that, I will start drawing now free body diagram of individual block to generate the necessary equation. So let me draw a block of free body diagram of block K. So what is the free body diagram of block K? I have its mass MA and its weight I represent MA into G, and here I have my string. So this is string 2, so tension in the string T2. So I just cut this and I show this, and that is what is this diagram here. So weight acting down and this is up here, and that's what is equal to my acceleration. So I assume this all comes down, so that is MA times AA. So this is first diagram to apply Newton's equation. So what is the convention that I follow here now to write the equation in the free body diagram? I'll consider all upward force positive. So I will write that as for this second one I'm writing, right? For the block A I'm writing. So that's going to be T2 minus MA G, which is equal to minus MA A. Minus sign is because it's down. So this. So in this, now I do not know T2, right? So I can write this equation for acceleration. Let me write for acceleration is what I am interested in. So I can rewrite my equation like this, right?
So,
Yeah.
so can you just repeat the sign convention once again?
Repeat the
Sign
no, no.
convention. Because at the top you did down is positive and up is negative.
That is, yeah. 1 minute. What is that? Okay, you can follow the same. So the same way you take it, that motion under down. So here I will have this is plus, this is minus, and this is plus, right? Nothing wrong. Yeah, take it like that. So now I can write my expression for AA. So that's going to be this MA goes here off, and this is going to be G minus T2 by MA. So that's going to be AA equals G 9.81 minus T2 by MA. MA is 2 kg, so it is 0.5 T2. So that's my equation 1. Equation 1 I am writing for AA, acceleration of block A. Now let me write similarly for body block B. So block B, what is that free body diagram? I have its weight. B is weighing 4 kg, so 4 times G, and the tension is T2, and that's what is equal to its acceleration 4 into AN. So applying this similarly equation, I have 4G positive minus T2, that's equal to 4AN. So I have my, this is B, not AN, AB. AB. So I get my AB equals G minus 0.25 T2. That's my second equation. That's my second equation, AB. Now, what is my third equation? I will get that from drawing free body diagram of this. C. So it weighs 6 times 9.81, and the tension in that is, since it's a cable 1, I'll put that now tension in the cable T1, and that's equal to 6 into AC, acceleration AC. Right? So when I write the equation 6G minus T1 equals 6AC, so I get my equation AC equals 9.81 minus 1 by 6. So 1 by 6 is 0.167 T1. So that's my third equation. So in this now I have how many unknowns? 3 acceleration and T1, T2, 5 unknowns. But I have only 3 equations now. So how do I go about solving? Then I have to solve for my tensions. So for that, let me look at now free body diagram of D. So free body diagram of D will relate to what is my T1 and T2. So moving pulley, that's what is I consider. So I have here 2 cables coming out. So that's T1, sorry, T2, T2, and this cable T1. And since the mass of this pulley is neglected, I would not have an inertia or effect force of this. That is neglected. That's equal to 0, I'll consider. So that gives me T1 is equal to 2 times T2. Applying sigma Fi equal to 0. So this helps me to now relate and write an equation from first 3 equations written. So what are the first 3 equations written? Let me rewrite that here again. So first equation is AA is equal to 9.81 minus 0.5 AA equals 9.81 minus 0.5 T2. That's my equation 1. And equation 2 is AB equals 9.81 minus 0.25 T2. And third equation AC is 9.81 minus 0.167 T1. That's my third equation. So now I can substitute this T1 is equal to 2 T2 in this, and then I can add all of them. I will have my one equation, right? I will have one equation. That's one thing. And let me write now the consistency of string law. So, right, that is also going to be giving me some additional equation. So this is my fourth equation. What is my fifth equation is I will be getting that equation from this law. So what does that say is that string length remains constant. So how do I get that now? That let's see, look at it. This is given one. So this is fixed pulley and this is moving pulley. So let me consider the position of this pulley is fixed now, correct? So from here, if I consider the position of this block is down, let me call that as the distance xc, and position of d, position of d from here, this, right? So this, how do I get it? If this is xc and this is xd. So xc plus xd is what is constant, right? xd plus xc is what is constant. That's one equation. So let me call that as a small Roman letter 1. So this distance sum, see, this is string 1, this is string 2. Yeah, I have downloaded your attendance. You can proceed and you can count it.
Sir,
Yes,
sir, this xt plus constant how, sir?
what happened?
This xd plus x equals to constant, sir. How it is possible?
Because that is the length of the string. See, what is that I measure is the length from here. There is a part of the length which is going around this pulley. That is again constant. I am not considering it. From the center of the pulley, what is this length and this length? Some should be constant. This portion is going on that side. That's I'm neglecting it. But this length are the variable length. So xc will vary as this comes down, and xd will be varying. As this goes down, the same amount xd goes up. So there is a variation in this length. But the varying part addition should be constant. That's what is consistency of the string. The length remains constant for this. So when I write this change in xd plus change in xc, then it is 0. So if I differentiate this with respect to time, I'll get a velocity relation. Then further differentiation will give me acceleration relation that says AD plus AC equals 0. So AD equals minus AC. So that's my fifth equation. And similarly, I can write an expression for the string 2. So string 2, you look at what is the constant part of my varying length. This is A and this is B. So I will express this distance from here like this. So from here, this part of the length, I can represent how from this point, whereas this is positioned as XA, and the XT is this part of the length. So minus XD is what is this part of the length. So this part of the length will be XA minus XT. Similarly, I can write this part of the length will be XB minus XT. And these two sums should be constant. So XA minus XD plus XB minus XD, that's equal to constant. The change in that, if you look at, so when I rewrite this, it's XA plus XB plus minus 2 times XD, that's equal to constant. So the change when it comes, that's equal to 0. So that is implying delta XA plus delta XB minus 2 delta XD equal to 0. So differentiating this with respect to time twice, I'll have an acceleration relation. AA plus AB minus 2 times AD equals 0. That's my sixth equation. That's my sixth equation. Right? So now how do I go about solving my problem? So in this again, you see, I want to eliminate XD. So I have here AD is minus AC. So I can eliminate this AD. So putting this, put in 6. I'll have my seventh equation. So that is my equation A plus AB plus 2 times AC equals 0. That's my 7th equation. Right. So now how many equations that I have here? Now 4 equation and this one additionally 5 equation. So look at 1, 2, 3, 4 and 7. So there are 5 equation now. There are 5 unknowns and I can solve the problem. That's all. So this is the equation and these 4 equations. So equation 1, 2, 3, 4 and 5 and 5 variables. So I can solve them simultaneously. So that's what is set completing this problem. So if you do so solving, right, you would be able to get these answers. So I will just write this answer and you can verify as in a homework problem. The answers are so I need to get acceleration. I just put the answers for you to verify. I have acceleration when I solve this. I get minus 4.026 meter per second square. So what I mean by minus sign, when I get minus sign, I assume AA comes down, but it is not so. The acceleration is upward. So that is 4.026 meter per second square going up. That is AA. Right? And then what is AB answer? You have to get 2.893 meter per second square when I solve. This comes positive, that means the assumption is correct, that comes down. And what is AC? So AC also comes out to be positive value when I solve a meter per second square, that's down. So only one, this comes negative, so the direction should be changed. So these are the absolute acceleration of these 3 blocks. You can also work out, if you know this acceleration, I know what are the tensions in cable 1 and 2. That you can additionally work out if you are asked that also, right? So that completes this problem. So these are the kind of problem which is all falls in the category of kinetics. Why? Because here the data of the problem is such that you are asked to find out acceleration straight away. You are not given any motion parameter data. Like in a rigid body mechanics, you are having a double pulley where one block velocity and the initial position is given, then you can find the other block, and then there is a kinematic relation that we have studied. But here this problem is not posed like that. Rather, you are given masses. Any time in the problem statement, the mass is given. That is kinetics problem you can consider. That's one way of looking at kinetics problem. Or you are asked to find the acceleration. You are given forces. That is again a kinetics problem, where you should apply Newton's law if the motion of the blocks under observation in the problem are translating. So there are 3 blocks here translating. Additionally, one pulley is translating. Since the mass of the pulley is neglected, you do not have their acceleration of the block pulley considered, but these 3 could be found out. So when you are writing this Newton's equation for these 3, you are having 3 equation that comes from the fundamental governing equation, but they are not sufficient. There is 2 additional variable. Those are tensions of the cable. The tensions of the cable to get in dependent motion, there's something called the consistency of the string law. So you look at the string as one element which is also undergoing motion, and when it is undergoing motion, the string is under acceleration. So point in the string acceleration can be the point where it is attached to the block or pulley. That's what you are understanding and relating it like this. And this equation number 5 and equation number 6 comes from the consistency of the string law. And you can eliminate AD from this so that your equation 7 you get it. So these are 4 equations. Additionally, you have this equation from this free body diagram. So you have 5 equations and 5 unknowns, and you would be able to find out. So you can also find out in this case what is T1 and T2 if it is asked. So that's all the kinetics. We'll solve some additional problem in the next class. Also, we will see another interesting